Okay, so this is the bench variable voltage supply I built, and not a whole lot going on here. It's 3 different taps, so I have variable, I have my 12 volt, I have my 5 volt off on switch. I have this little LED readout here, it's just a couple of 7 segments, and that's my voltage. So it says 345 there, and then I get 3.42 up there. So we don't know if it's the Mastercraft multimeter that's a little wrong, or if it's this thing. I can adjust it anyway. I'm not too worried, that's close enough for me. So I've added fine and coarse controls. So the LM317 actually likes to have a 5K pot attached to it. Well, I guess depending on what you're doing. And I fried it, so I used a 10 and I used a 1. So I have my coarse adjust here, and then I can just tweak it in a little bit. So if I want 9, there we go, life is good. And again, a little off up here, I'm reading 8.95. I might look into that later, not really a big problem. So the reason why I do have the 12 volt and the 5 volt specifically, well, the 5 I wanted because I do a lot of microcontroller stuff. But I put the 12 in because that's actually powering this cooling fan, because I kept going into thermal overload whenever I put any real load on anything. So that's cooling the 7805, the 7812, and the LM317. And so that's cooling that. The 5 volt rail, though, is also powering this voltage meter. And there's not a whole lot else going on here. The banana plugs, I can either just screw the wire in, or I can put in banana plugs. So for fun, let's move this over here. And so there we go, 11.75, I can live with that. And on my 5 volts, whoops, I should stick it in the right one, 4.96, I can live with that too. That's good. So, cooling fan, you should have bigger heat sinks on this, but I didn't really want to deal with buying them because I already had the 12 volt fan laying around, so we did that. And it should hopefully never overheat. And the nice thing about these packages is that when they do go into overload, they just shut off. So your project might start doing something funny, but hopefully nothing gets wrecked. So I can go down to 1.27. I bet you would say 1.25 on the other meter. And then if I crank everything, 16.7. I'm actually using a laptop power supply to feed this thing because I couldn't find the proper transformer I wanted, and I was trying to keep the price down. So basically the transformer only went to 18 or 19 volts, but I still put the bridge rectifier in, so I lost 1.4 volts on those diodes. So that's what I get. But if I ever come across a 75 VA transformer with a 24 volt secondary, I'll toss that in. So it's already built for that. I can show the inside of this thing too, actually. Smell my junk laying around here. So I built this into a snap and lock Tupperware container from Dollarama, which was a nice little touch. So there's the fan, and there's the proto board. So I use screw terminals to put everything together. There's some 3300 microfarad caps, little heat sinks, but they do sit right under the fan. So life is good. And the banana plugs, a little bit of hot glue, and yeah, there's some speed holes there to get the air moving across. So there you have it. This thing probably cost me, I don't know, we'll say 30-40 bucks to put together, and a comparable bench power supply, hundreds. You can buy cheaper bench power supplies, but usually they're just resistors and they're boring, and you don't get this kind of control with the variable supply. And interesting enough, when it's actually this dead, look, the capacitors are still slowly discharging. Okay, well there you have it. That's really all I have to say about this project. So if you're trying to build one, good luck. On my blog I'll post my schematic and some other info, and great, enjoy.